Hello students, let us solve some examples based on theorem of internal division of chords, theorem of external division of chords and tangent second segments theorem. Now let us have another question. Diagram is given. This diagram, length of segment PQ is given to be 6, length of segment QR is 10, length of segment PS is 8, and from that we have to find the length of segment PS. Now here as we can see, PS and RQ are the two chords of a circle. If we extend these chords, we can see that these two chords intersect at point P in the exterior of the circle. That's why here to solve this problem, we have to use the theorem of external division of chords. By that we can write PS into PT, that is equal to PQ into PR. Here we should note that we have to start with the external point P and get the first segment PS. Again we have to start with P to get the second PT is equal to the same way PQ into PR. We are given the length of segment PS, that's 8. We are given the length of segment PQ, that's 6. But we don't have either PT or PR because the length of segment QR is given. So first of all, we should find either the length of segment PT or PR. So first of all, we should find that. For that we use the relation here. PR is equal to PQ plus QR. It is the sum of length of these two smaller segments PQ and QR must be equal to PR as P, Q and R are collinear points. So we have to find the length of PR. PQ is given to be 6 plus QR is also given and that is 10. 6 plus 10, that's 16. So length of segment PR is 16. Now we can use the length of segment PR in this equation. So PS is 8, PT we have to find, so we'll keep as it is equal to PQ is 6 into PR we have just found to be 16. That is 6 into 16. If we take 8 to the right hand side, it will be in the denominator. Get the equation PT is equal to 16 into 6, that's 96 divided by 8. If we divide 96 by 8, we get PT is equal to 12. But that is not the question. We have to find the length of segment TS and not PT. So we have again one relation. PT is the sum of two smaller segments PS and TS. We can write here PT is equal to PS plus TS as P, S and T are collinear points. So we have the length of segment PT, that's 12, is equal to PS is given to be 8 plus TS. If we take 8 to the left hand side, it will be 12 minus 8, that is equal to TS. So 12 minus 8, that's 4, is equal to TS, that means TS is equal to 4. So the length of segment TS is 4 units. Let us consider another problem. This is the figure given. This question is segment EF is a diameter and segment DF is a tangent segment. The radius of this circle is R, and from that we have to prove that product of DE and GE is equal to 4R square. So if we consider angle EDF, that angle, one side touches the circle and the other side intersect the circle. So as this is the situation, in that case we have to use tangent secant segments theorem. By that we have to write the tangent segment square, that is df square, is equal to dg into de. This is the relation we get by using tangent secant segment theorem. Now we know that tangent is perpendicular to the radius. So df is a tangent and hf is a radius, or we can say ef is a diameter. That's why this diameter ef must be perpendicular to df, which is a tangent. That's why we get segment ef is perpendicular to segment df. This the angle between these two is 90 degree. This angle EFD is equal to 90 degree. Now it is given that the radius of the circle is r. So we know the relation between diameter and radius of a circle. Diameter is always double the radius. That's why the diameter EF must be 2r. Now as we have proved here that measure of angle EFD is 90 degree, that means triangle DFE must be right angle triangle, and in that right angle triangle DFE we can use Pythagoras theorem. By that we can write the hypotenuse square is equal to side 1 square plus side 2 square. So this is a right angle triangle where DE is the hypotenuse. So we can write DE square is equal to, remaining two sides are DF and EF. So DE square must be equal to DF square plus EF square. So we'll keep the left hand side as it is, that is DE square is equal to DF square plus EF. EF, that is the diameter, is 2r here. So we'll replace EF by 2r bracket square. We get DE square is equal to DF square plus, we have to make a squares of both of these two, that is 2 square is 4 and square of r is r square. We'll get the term 4r square. Now we'll take df square to the left hand side to get equation de square minus df square, that is equal to 4r square. Now if we interchange the sides, we get 4r square is equal to de square minus df square. Now here we have proved that df square is equal to dg into d. So instead of df square, we can write dg into d to get an equation d square minus dg into d, that is equal to 4r square. Now we have two terms d square and dg into d. From these two terms we can take d as common. So if we take d as common, inside bracket we should have de minus dg, that is equal to 4r square. Now if we see in the diagram, if we observe the diagram, de minus dg, it should be ge. So if we subtract dg from the larger segment de, we get ge. That's why instead of de minus dg, we can write ge. So we get de into g, that is equal to 4r square. That is we wanted to prove.